Hello everyone, this is Orhan. Welcome to the Neural Nets application lecture. In this video, I will be showing you a couple of neural nets examples in Python. Let's dive in. Okay, I will start this lecture by a very little tiny example. So let's import the libraries first. So these are the libraries that I will be using. And now I'm going to import the data, which is called tiny data. This data is from Data Mining for Business Analytics textbook. And it's a very small data, which I will show you in a moment. So let's call this example df. These are the first 5 rows of the data. In fact, this data has only 6 rows. So there are only 6 records here. First column is fat data, second column is salt data, and the last column is whether the customer liked the cheese or not. So now we are going to create the predictors, outcome, and the neural net structure. Okay, let me correct the error here, run it again so it's working. Okay, in this code we are asking Python to produce 3 hidden layers, and we are going to use logistic transfer function. And these outputs shows us 2 things. The first one is the intercept, which are the biases, and the second one are the weights in each node. I am going to explain one of these numbers here just to illustrate my point. So I'm going to explain this last intercept here, which is 14.3. As you might remember from our class discussion, we had 3 biases, and one for N3, one for N4, one for N5, and one for N6. For N6, we started from negative 0.015, and then the model updated it from negative 0.015 to positive 0.047. I just stopped there, but basically the model does not. It keeps updating it until the new values of the bias and weights are only incrementally different from those of the preceding iteration. So the model kept updating it until it reached 14.3. So basically, this 14.3 is the last bias which belongs to node 6. The same holds for other biases and weights too. Now let's take a look at our predictions. Okay, so as you can see, it added 2 columns here. The first column is probability of dislike, second column of probability of like. When the actual situation is dislike, the probability of dislike is really high here. It's the same thing for this record and this record too. When the acceptance is like, the probability of acceptance is also high. So the prediction power of our model is really good. Now let's take a look at the classification matrix. Okay, as you can see, our precision is 100%. We predicted every single record with perfect accuracy. So that's why this precision and recall are very high. So we have 6 observations and all of them are correctly predicted. Now let's take a look at another data which is very similar to this one. So I'm going to call this sample df. Okay, as you can see, this time I have 5 data, and then I have balance and income of some customers, and I see whether they are defaulting or not. Now I'm going to ask the neural network to predict if these customers are going to default or not, using more or less the same procedure. the rest of the procedure is more or less going to be the same, so that's why I'm going to copy and paste it from here and then change a couple of things. So copy this thing and paste it here. So the only difference is going to be x2, y2, x2, and let's also call this CLF2. Okay, so these are going to be my biases and weights. And lastly, I am also going to copy and paste the predictions. So this is not example, this is sample, and CLF2, X2, and that's it. So let's run the code. Okay, as you can see, so the first observation defaulted, and the probability of default is higher than probability of non-default. Second guy did not default, so that's why the probability of non-default is higher. So it is pretty accurate except the third and the fourth observation. So their probability of defaults are the same, even though the fourth record did not default. Now let's take a look at the classification and confusion matrix, and you will see that that's not very successful. So I'm going to copy paste here. So this is y2, CLF2, and then x2. So as you can see, the precision is not that high this time. It's 83%, just because some of the observations are not correctly predicted. So in the third example, I'm going to be using a real data from Data Mining and Business Analytics book. This data is US automobile accidents data that have been classified by their level of severity as no injury, injury, or fatality. A firm might be interested in developing a system for quickly classifying the severity of an accident based on initial reports and associated data in the system. Now let's take a look at the data. So the first column shows the presence or absence of alcohol, and second column shows the profile of roadway, level 1 or 0, so level 1 or not. Third column shows surface condition of the road. 1 stands for dry, 2 stands for wet, 3 stands for snow or slush, 4 stands for ice, and 9 stands for unknown. So this column, vehicle involvement, shows a number of vehicles involved in the accident. And the last column is the column that we are going to predict. It shows the presence of injuries, fatalities. 0 stands for no injuries, 1 stands for injury, and 2 stands for fatality. Now let's go ahead and try to predict this using train test split. So the precision performance of our model is almost like a macro average is 86% and weighted average is 87%, which is quite high. But this is for the trained data set. We have to check the test data set too. So I'm going to copy this and paste it here and then change this train to test F. And then, so this is going to be test X. So it's also very similar. So basically, so this is the performance of our model, both in the train and then test data, which are quite high. So there are three classes in our data set. So the first class is, so the precision in the first class is, which is basically no injury, 90%. The precision in the second class, which is injury, is 78%. Third class, which is for fatality, it's 83%. The weighted average precision is 86%. In this video, I showed you how to run neural nets framework in Python. And we used three examples, two of which were a tiny little data set, which are simulated. And the last one was a real data set. I hope this video helped you understand the basic idea of neural nets. Hope to see you in the next videos. Bye.